summer, and welcome back to the Green Register's event schedule. So we're just starting up again for the autumn, which is really exciting. So it's really great to have everyone back. And today we have Pierre Bidaud from the Stonemasonry company. Pierre, if I haven't pronounced your name correctly, please do correct me. I'm very happy with that.
No, it's fine. Don't worry.
Okay, right.
So far, so good.
Okay. Pierre's a stonemason, and he is going to, welcome back to the new project, I suppose we should say. Pierre's going to be talking about the sort of past of stone, the current use of stone, future of stone, and its low carbon use. So we're really happy to welcome him. And also, while I'm here, I just wanted to mention that we've got another event on Wednesday, which is how to internally insulate solid stone and brick walls. So that kind of relates to this event. And I hope you'll be able to join us for that one as well. That's going to be at 9 to 11 a.m. on Wednesday, and I will post the link to that in the chat shortly. And if you're not already a member, then do hop onto our website and check out membership too, because you can save quite a bit on training events and various other things too. And we love that. I'm sorry, I've got a cat zoomed on me. Off you go. So I think we all know the drill with Zoom. If you wouldn't mind just keeping your mics off until questions, which are going to be a bit later on. Pierre's helpfully going to answer some questions for us, but post them in chat if you'd like to, and we'll pick those up a bit later. I am going to stop sharing my screen and hand straight over to Pierre. Thank you so much.
Hello, everyone. So I'm going to share my screen. So looks like everybody can see my screen now.
That's perfect. Thank you, Pierre.
Fantastic. Right. Good afternoon, everyone. Thank you very much for the Green Register to have had us in this interesting talk. Interesting talk. It's going to be interesting because I'm an interesting person, so it cannot be interesting. I'm going to talk about stone as a load-bearing material. So there will be no chat about or no long speech about marble work, worktops, marble bathroom cladding, flooring. All that is not something that is of any interest to us. We are very much about reintroducing stone as a structural and load-bearing material. So just to introduce myself, I'm a stonemason. I've been a stonemason for 30 years. And the last 10 years, I've been doing some project management, research and development, a bit of creative work on the load-bearing side of stone structure. I'm going to talk a bit about these four headers, which is the trilithon, what is a quarry, so a portrait of a quarry, what are they about, and so on. In the end of the makers, the important bit for us is how you make those stone buildings, what sort of new technology we are using, and of course, what we can expect of nearly 6,000 years of learning about stone, and the last 20 years with new technological development. Right. So the trilithon. Trilithon, a proven system. It's and a safe way to build. And under that header, I want to share a bit of what I called my lithography, which is the wiseness of stone. And the very first one I would like to introduce in this lithography is that stone for us is not a luxury but a commodity. I think we in the last 50 years, good 50 years, we have lost this intimacy we had with stone when it was for purely building. We became master at using it as a veneer and cladding, but we totally forgot about its very first and its strong potential as a building material. I think that when we look, I know it's going to be quite quite a trip, but when we remember Stonehenge, when we look at Stonehenge, we look at a very primitive way, of course, of putting stone together. But strangely enough, these two columns, that lintel linking the two columns, are such a basic, simple, but still so safe way of protecting ourselves, of coming together under those mineral skies, that I think we need to reconnect with this simplicity of working. And never we should never I don't call that miss an opportunity to put a William Blake lithography as a in a talk, because they are just so beautifully executed and show as well, especially that one as a building material, as a sacred material. What I mean when I say sacred, I just mean that anything that is quarry extracted from the earth, we should very much take care of it and make it as much as possible out of it. And so a sort of a war against waste. And as the technological side on the right-hand side is, of course, this beautiful wall section of Roman walls in Algeria, which of course they've been rebuilt since. But you can see how steady our stills they can be put together and be of use again if we really want it. So what's fantastic is that I've been lucky enough to travel around the world and see some amazing stone structure. But something we forgot is that how basic this material can be. And on the right-hand side, on the left-hand side, you can see two 6-meter tall stone pillars. They are monolithic stone pillars, and those pillars were extracted away 100 miles away from Lyon in France on the Rhone river. And those pillars are part of many other pillars used in the city, not as a decorative material, but very much as a natural concrete. Okay, as you can see, these pillars have been just roughly hewed with a pitch and left like that, and we're going to be cladded in wood. Okay, because these were ground floor shops. They were just also just standard shops, and they were going to have a sort of wood cladding to protect it and hide its rusticity. And of course, nearly 150 years later, we bring this cladding down and to reveal the amazing stone. And I think it's this ability that we lost of understanding that stone has got just to be simply extracted from the ground, put on a truck, bring on site, lift it up, and so on and so on and so on. It should become again mundane as it used to be. And on the right-hand side, you can see, in fact, it's exactly what has been how Lyon was built in the 1850. It was just those massive lintels or flat arches just assembled on top of these simple stone piers. And if 150 years ago, knowing that all was coming by horse cart, ox cart, just brought 50 miles away from the quarry, put onto a ship, brought down the Rhone, unloaded, put again on a cart, and just erected again, and that was still a commodity material. How come we cannot do it now? And I think it's this little, this very simple illustration that I've made. They are really, very much a general illustration, and you can see how that limestone. Let's talk about limestone. So standard limestone, Jurassic limestone, 135 million years old, with usually a compressive strength of 40 MPa, very similar to concrete. How this incredible material has been losing its potency through the age, and most importantly, it became quite it became really starting to be a decorative only material when the steel industry started to have those this very 1900 Regent Street sort of building, steel frame with that semi-load bearing stone, and of course then through the modernist, the stone getting not only thinner but just really as purely decorative, until of course when it started to be put on aluminium backing with epoxy resin and only in 30 millimeters thickness, against pin to a material which has been handmade, which has been done using a huge amount of energy, which is of course concrete. So I think it just shows how the way of building has been driven by the energy use, and how the more energy we have, the cheaper it became, the sort of more wasteful we became. So I don't know if, like me, you become addicted to carbon footprint illustration grids and vignettes and so on, but rarely you will see on those vignettes, on those illustrations, stone appearing. All right, it's always missing. May it be a pyramids of usage of carbon, or it could be any how to put it, any illustration of different material in the construction industry. Stone rarely appear, and if it appears, of course, it is as a cladding. And on this drawing, on this illustration done by a third party, you can see that stone is as close as cross-laminated timber in its use of CO2. And I think even that doesn't give a right the right number, because I think it's much lower. And as compared to, of course, reinforced concrete, it's very much a big difference that you can see. And I am afraid I've got to draw a sort of comparison with where we are at the moment and France in 1945, just after the war. Why? Because I think that what we have to deal with nowadays is very similar to the crisis of 1945 France. Is that we've got less and less qualified labor that we can rely on, which was the case in 1945 and very much us now. We've got energy that's starting to be a lot more expensive, and we are going to start to pay the real price of energy, I think, from nowadays. And again, you can see the similarity with France in 1945, where coal was extremely expensive, and when we had to rebuild France, we had to find material that was very cheap in energy. And the French government decided to do this very interesting energy cost comparison between concrete and stone. And they just find out in 1950 that you needed 225 kilograms of coal to produce 1 cubic meters of concrete, when for the stone, you just needed 10 kilograms. So what happened is that French just asked its stone industry to completely pivot to a highly industrial model, where they could churn out huge numbers of stone ashlars, of stone lintels, and so on, to rebuild affordable housing. And I think, it's very much the same way as we are now, where on top of that now, we've got to produce building with a low carbon footprint. Again, in 1950s France, you needed to build a lot of social housing, affordable housing, and stone completely made it possible. And I think is through the short study I'm going to give about, the short study I'm going to show you about 15 Clerkenwell Close by Aminta Group work in 2016, you will be able to see that we managed to resolve quite a lot of those conundrum. Again, all that based on a very simple way of building and very much a safe way to build. So I do not know how many of you know about quarry, about extraction, but they come in all different shape and sizes, different flavor. And the very first thing, I mean, again, my lithography quote is that, you know, when I said you should listen to the quarry and draw in its dots your building, in its dots its building, it's very simple. Is that it's the quarry who is going to drive your project. Okay, you shouldn't ask the quarry, the stone in the quarry, to do something that it cannot do. You cannot ask for a quarry who can only get a small stone modules to have large and long and extremely strong monolithic lintels. Okay, and I think it's something that people need to understand. So I'm going to show you a couple of sort of typical quarry layouts, and from, you know, let's start. My colleague from south of France will feel insulted if I was going to say that, but a very bland and very easy quarry to stone to quarry, which is stone from Estallada. As you can see here, it is very much cutting sugar cubes out of the earth. Those are blocks which, depending, are 1.2 high by 600 mil thick or 400 mil thick, and nearly 1.6 long. So those blocks are going to be used straight from the quarry, put onto the back of a lorry, and sent straight to site to build. Okay. In fact, you have already prefabricated part of a wall right straight into that very bland and boring quarry. Again, do not repeat that to my friend from Provence. And of course, you've got the very hard to get, very how to put it, capricieuse, as we say in French, very very demanding, very beautiful marbled limestone from Italy. As you can see here, it's a completely different type of quarry. It's really a quarry where you are going to struggle to get your stone. You've got to have those massive wire cutter system that you can see here. This big wheel just turn at high speed a very 10 millimeters diameter wire that's going to cut through the stone, and you are going to get pretty different blocks from one day to the other. Okay, they are not going to be really an homogeneous kind of blocks, and it's also a very hard limestone to cut. As soon as you see a diamond wire on a quarry, the stone is usually meant to be very hard. And of course, you've got the very discrete, extremely discrete quarry, which you cannot even see because it's underground. So you've got two of those quarries in the UK, which is of course Bath stone and Portland stone. Here it's a quarry in north of France, where we've got a lot of those quarries. And of course, when I say it's discrete, is that of course you cannot see at all. They are just usually 10 meters underground, and due to their geological makeup, they they are extracted in blocks of a very standard and normalized size, because the machine that are going to be used are going to be extremely efficient in the way they are going to extract the material. What's happened is that, like in a seam of in a coal seam, you are going to have a limestone seam under the ground, and you are going to follow its height. Some will be extremely shallow height, like this one, which is just 2 meters or 2.5 meters, or you can get, of course, much higher ceiling height. If you go to Portland, it's really huge. And of course, you've got to read a quarry. You've got to read a quarry. You've got to understand its all its cracks, all these layers. Some quarries in south of France or in Spain or Italy have been used since the Roman. So there is a huge amount of knowledge on the way the quarry, how you've got to behave with that quarry. It's about reading really what's Earth has been cooking for us in the last million years, and it's going into between cracks, between seams, that a good quarryman will manage to get as much stone as possible. Here you can see on the left-hand side a beautiful drilling by a drilling rig that splitted the stone. As on the left-hand side of that same pictures, you can see the wire was been cutting right through the material and making that fantastic straight face that, of course, will be recut later at the mill plant, at the sewing plant. But you can see the size of those blocks; they are very, very big. They have been extracted extremely carefully, but extremely efficiently as well. I cannot tell you the amount of work that by hand it would have been done, 100 years ago, 120 years ago. As nowadays, it's just more or less semi-automated. The rigs that drills are automated. It's the quarry industry, extraction industry of dimensional stone has improved a lot. And of course, most of those quarries have what we call beddings. Okay, so a bit like wood has got all these layers. These are these rings. Stone has been shaped. Jurassic limestone has been created by organic matter, just gathering at the bottom of the ocean or lakes or whatever. And you've got to be very careful in the way you are using those beddings. But as sometimes people would think that those beddings need to be put back into compression, so that the pressure has got to be perpendicular to its bedding. You will see, strangely enough, in some vernacular architecture, quarryman who's been decided to use it the other way around, which engineer would say should not work like that. But strangely enough, for the last 600 years has been working perfectly well. So not that the quarryman is a risk taker or the engineer risk averse. It's just that we are still in the process of understanding why some stone can be worked against the bed while the other one cannot. So again, it's an intimacy that we all have lost. Architect, engineer, but even a stonemason on the way to build with stone as a load-bearing material. Now, so when I say at the beginning of the talk that we should respect stone and stone is sacred, is that in the good old, not in the good old days, in the old days, because I'm sure that the sawyers on that illustration will not be too keen on the good, but to extract stone, to shape it, you needed a lot of human energy, and of course animal power as well. And I think we lost perspective on that, and do not realize how much effort went into the making of this incredible structure. You can see on that pictures the slabs being cut with a metal, an iron blade, and the two barrels that you can see on top of the blocks should be maybe for sure some sand, some silicate that's going to be put into the groove and just grind the stone, and sometimes to speed up the process, a bit of water, depending on the hardness of stone. And of course, that was very much in the 18th century. From the 19th century, with hydraulic power and so forth, you start to drill with these big pneumatic jacks, pneumatic drills, as shown by Epstein here, which are going to speed up the extraction process. Now, as I was saying earlier, especially for hard limestone like granite, like marble, you use these cable wires. So these 10 mil diameter cables with tungsten diamonds weld to it will cut through any material and can cut up to 10 square meters of material easily. And as you can see, the finished product on the right hand side, where the bottom of the quarry, you can see that very bottom is a natural crack that occur in the Jurassic time. It might have been a clay deposit. It might have been any weak deposition of sediment. And on both sides, you can see this huge how to call that waving of the cable that was created while it was being cut. So it's quite extraordinary what the advance in extraction that has been done in the last 50 years, 70 years, and even more in the last 10 years. Because in the last 10 years, something that has come and changed quite a lot of things in the quarry is the use of, of course, most of the tools that you are going to see in a quarry have got electric motors, but those big chains that you used to see only in workshops and so on, those big chainsaw now are being mounted on special rigs and can do the pre-cutting straight at the quarry, and can even carve straight into the quarry at a speed that I 10 years ago you would have never imagined. And those machines again leave some very interesting pattern, very much like the extraction tool of the Roman quarry master. Those marks in the stone are very much the contemporary marks of our tools, our modern tools, and should be as well celebrated, and not always they should be disappearing at the surface of the building. Here you can see the rigs, and for your information, Clerkenwell Close, 15 Clerkenwell Close was extracted. The 100 cubic meters was extracted by the 3 people here on the picture. Yes, again, it's a testament to the evolution of stonemasonry. Of course, the splitting in this particular quarry still need to be done using plug and feathers. But if you were going to go in Norway, they would have complete automated rig that would do that with hydraulic jacks and with no manpower on site. And here you can see that on the left-hand side, that chainsaw, that huge chainsaw cutting perpendicular to the bedding. So it's in a horizontal cut, which are cutting the beds, and these are easily transported on a digger or anything with tracks, and can be put and moved into the quarry or wherever you want. And two of course, Aminta on the left-hand side, and Dominic, both the architect of 15 Clerkenwell Close. And I have this say that when you visit a quarry, when you go and walk on top of those giant blocks, you just feel like a conqueror. You just feel like you are walking on the plinth to your greatness. There is something special about visiting quarries and going and you know, losing yourself on this labyrinth of blocks. Sometimes you could have 500 blocks like that in a quarry, and it's quite it's a very poetic experience. Now, once the quarry has done its jobs, you just need to go at the plant, at the stone yard, to have it cut for the installation. And yes, being French, I always like to put a bit of French philosophy. So as Descartes say, I think it's Descartes who say, "I think, therefore I am." So I carve, and therefore I am. And it's something that I have enjoyed for a very long period of time while I was on the tools. But the job that you've seen at Clerkenwell has been done by only one man, Régis, which happened to be also my apprentice in '93 in Marseille. And Régis, who is now a sculptor also, did all the cutting for the connection of the connection box for the Clerkenwell project, and very simply with a disc cutter and some chisel, he did most of the connection on the 100 cubic meters of stone. And you can see here you can just see on the left hand side those pillars and beams that have been worked, ready to be put on a lorry. As you can see on the right hand side, you have the stone on the back of the lorry, which are going to be lifted into place. What was one of the challenge was obviously a tight space on site at Clerkenwell, and we just have to rely on a very short chain of supply where all the lorries were coming at a certain date, very much like a precast system, a precast concrete system, one lorry at a time every 2-3 days, store them quickly on site and just erect the structure. Again, very, very close to precast concrete. So here you can see on the left one of the pillars being lifted up in the air. Those pillars, as on the right hand side pictures, those pillars you can just see. I think I've got, yeah, I will show it later. But those massive pillars and lintels are taking the load of each concrete floor. Okay, so it's the structure at Clerkenwell Close is very much a load-bearing stone structure. It all the building is connected to that exoskeleton, and this exoskeleton is fully load-bearing. What you can see here is the connection on the left-hand side of pillars and a lintel, and on the right-hand side you can see the connection box that's going to be connected to that exoskeleton to the concrete floor. Okay, so I think with Finsbury Circus building by Eric Parry, those are very rare stone structure in the last 20 years that has been fully load bearing. Okay, and of course on the left-hand side pictures, you can see that female connection box was being casted into the concrete. To avoid any cold bridge, we inserted between the floor, the concrete floor, and the back of the stone of the exoskeleton, a foam glass element to stop that cold bridge. So here you can see the structure being put in place, with obviously the yellow, I'll call that the yellow props, because in fact the concrete structure went first, and then we came with the stone element after. I mean, it was just a question of synchronization. We would do it again. We would do floor by floor, of course, to avoid the expensive propping up. And of course, on the right-hand side, you can see the finished building. And as much as you need an architect and a stonemason, you of course need an engineer. And I think in most of our projects that we are doing, we try to, the stonemasonry company and the team tried to be very close, and to the engineer that was on site, what was Steve Webb, and the architect. Those stone projects at the moment demand a very close partnership, a very transparent partnership between these three people on a project. And it is very much recommended that the stonemason, the choice of the stone was done quite early in the project, so that you can be as efficient as possible in the use of carbon by the way you are using stone, and the style of the module and pattern you are going to use for your building. Return to the future. So those elements that you see, that you saw earlier, were just monolithic lintels and columns. What happened is that stone is a natural material, and it's got default, I mean, it's got faults, cracks, anything like that. And in the last 6,000 years, it's through engineering, it's through efficient extracting, efficient shaping, that we managed to sublime a material which is, of course, flawed. I think when we work natural material, when we work with those natural material with flaws, we very much work with ourselves too. Okay, it's just that we just discovered that those materials are very much as human as we are, and we have fault as well. And I think people who like to work with natural material are usually people who get on well with other people and the human race, and doesn't try to make a sort of, sometimes I use that term, which is maybe not the best, but a very eugenicistic architecture, where you've got a bland facade, bland colors that match every, you try to make the quarry do something that it shouldn't be by selecting and extra selecting your material, just putting the stone that doesn't fit the criteria. But I think it's a big mistake, because in a society where we have got so much diversity, it would be awful that if we started to say, oh, you've got a little scratch on your nose, you cannot come to the practice, or whatever other reason. And I think we need to be very careful that we need to embrace that whole flawness of this whole flaw that we have in our natural material. And all quarries are not like the quarry I showed before for Clerkenwell Close. A lot of quarries have a deselected, unselected material that are mechanically good, but cannot unfortunately be used as a load-bearing material, because too small, because not the right size, etc. So our proposition is very much to do this sort of stereolithic architecture, where we would take all the things that nobody wants, all the unloved stone, visually challenged piece of stone, and put them all together through a pre-tensioning system prefabricated at workshop, and so that we can bring in one piece those multi pieces, these multiple pieces of stone. And it's what we are doing. As you can see on the left-hand side, you've got all these happy stone that nobody wanted at the quarry, and that with good engineering and a lot of love, we just put together and produce long beams, long columns, planks, and so forth. We just use a standard stressing system. When I say standard, the system is standard, but the process is far from being standard. We have spent a lot of time improving those systems, and now we issue days in, day out, up to 14-meter long stone beams or planks. We do the same with columns, all prefabricated to just speed up the process of setting on site, so that we don't have to hand set stone blocks like in the old days, where unfortunately at the moment we do not have the labor force, and we just need we are under time constraint, and we just need to move fast on site. And the point is one day to maybe reach a point where we would get this sort of framing system as on the left-hand side picture, where we would replace concrete precast with natural concrete cast system, which in fact is just stone, just reinforced, armed, a sort of stone on steroids that would be put onto frames and portal. On the right-hand side, you can see one of these huge beams, transfer beam, that we put on a project at the moment, which is as reliable as a large piece of concrete. And here are some pictures of a job we have at the moment. You can see the large soffit in reinforced plank stone system, but you can see also some of those large transfer beams, which are spanning across. And of course, on the other page, another project where we also have this sort of long system of Lintol beams and pre-assembled columns. Here, a mock-up you can see at our workshop. It shows all the different type of of columns and beams we can propose to a client. And again, very easy to assemble by precast specialist crew who know how to lift, how to crane things. It's again, we very much do not want at the moment to disrupt the method of construction. What we want is to challenge the use of material for those structure, but not the way they are built together. And something that was key to us for the last 15 years was the building of reinforced stone staircase, and that was usually done on site, hence the name post-tension, because we were doing the tensioning on site of those staircase. But now with our new technology, we even do them pre-assembled, and those staircases have been used to do that staircase on the left-hand side, on the right-hand side, which we couldn't have embedded into the wall, and we decided to just do a pre-assembled. And again, that's a very interesting job where we did all the spines wall in load-bearing stone, and the ground floor was in part in the first floor was all in wood. So a nice stone plinth at the bottom, and then the wood at the top. Yes, so Hades, do not mess with Gaia. It's very much something that very much is of in the news. It's fire and fire regulation. All our pre-assembled beams have been tested to fire. And as much as it make me cry each time I see all our beautiful stone put to the kiln. On the right hand side, you can see a 6 meter long reinforced stone beams, which been tested on the 20-ton loads for 3 hours. And as you can see, very little spalling, an incredibly well-behaved stone beam, who just show that stone beams on those sort of configuration are as good as concrete beams. So I think that's a big lesson to learn. We not only did 1, but 2, and even 3 tests with the same result. And yes, very much a sort of what I call not brutalistic, but brutalitic stone system that we could put in place. Here, some pictures of a possible project with Aminta group work, where we would be using load-bearing stone system of prefab exoskeleton frame. I think that's got legs. I think it would allow us to make our building a lot more efficient on their envelope. In France, in the last 70 years, we've been using stone extensively, as I was saying earlier. At the bottom on left-hand side, bottom left-hand side, that is Fernand Pouillon building, one of the many buildings he did for housing, affordable housing in the 50s. But on the left-hand side top, you can see 2020 building by Archiplein Atelier Perronin. It's 80 flats, 67 flats in Switzerland. It's all in load-bearing stone, internal wall, external wall, and of course, concrete floor slabs. Pictures in the middle, it's a beautiful French limestone in Paris. Again, another affordable scheme, all very much in the Haussmann way of building of the 1900s. Top right is another project by Atelier Perronin in Lyon, delivered by Wiswig Architect. Again, mixed housing. You've got workshop at the on the ground floor. You've got offices on first floor, and the rest is affordable flats. And the beautiful recent on the right low corner, the beautiful load-bearing cover market, all in local limestone. No reinforcement whatsoever. All those pictures, by the way, are unreinforced, traditional unreinforced. And the lovely covered market has been done by our colleague of Lada Studio in east of France. Again, a beautiful box of load-bearing stone. And finally, the new Stone Age, that is a poster I did a couple of years back, showing all the load-bearing stone structure that was done in France, and with our little attempt in England 4 years ago. There is 22 structural stone buildings. They are all completed. There is so many other buildings that could be built with stone. We just need to put the right argument across. I think that is something that we need to think carefully on the way we are seeing stone. We just have to change the mindset of developers, of engineers, of architects on how to use stone, because it's a material which got so much more to offer than just bathroom tiling and shopping mall floor. I think those buildings that I've shown you have got at least 300 mil thick stone walls. And as I tend to do, and as I tend to say, as my last lithography quote, any stone building is a quarry to be. So any solid building that you see that might have been built by the Roman, and then dismantled and rebuilt by the Gothic, and then dismantled and taken over by some Renaissance builders. This sort of perpetual use of stone can only be done if in solid states. If you are doing it in a 30 mil, if you are going to do a 20 mil cladding, you are never going to use that stone as it should be. And I think it's something that circularity of the material is another big thing. I think it's something we've got to consider with a lot more attention. So here we are. That's it. I think I'm just right on the time frame.
You've done brilliantly with time. Thank you so much, Pierre.
A pleasure.
That was super interesting. It's just great to find out a bit more about such an ancient material and its modern uses. We've got a couple of questions in chat, so we could pick those up.
Yeah.
Oh, I can actually find my chat. There you go. So the first one was from Lucy, and I think it's wheeling back a bit in your slide showing the comparative carbon emissions per square metre of various materials.
Yes.
Take into account the differing strength of each material. For example, rammed earth will perhaps be less strong than solid stone per square metre.
Yes. Yeah. No, it's something we need to be careful. Yes, it's when you compare material is, what do you do with that material? What's the MPa for each material? Do you need the same section of stone of prefabricated stone lintel? You need the same volume as the one in concrete, and so on and so on. So yeah, there is many ways you can compare material. And we need to be careful on the way we handle this material in this ratio per strength per carbon emission.
Okay, and actually there's another one from Lucy. How does the size of the foundations compare between a concrete frame and a stone load-bearing frame?
Same, very little difference. The density of stone is very similar to the one of concrete. So there's no impact on the foundation. And your foundation could be in stone as well.
Brilliant, thank you. Adam's asking, it all looks very impressive, thank you. How much does the post-tensioning add to the embodied carbon?
Good question. We have a lot less steel that, so we are still doing the calculation at the moment. So I'm not going to dare bullshitting you on that. So we are just very much doing the calculation on that. We are using nearly, only 20, we are using a very low amount of steel in the reinforcement compared to concrete. We rely a lot on the strengths of stone, or the intrinsic strengths of stone. Usually we're using just 75% less steel than in concrete. You see what I mean? Our rebars numbers and so on. So I do agree we still have some steel, but not in the same ratio as concrete.
Impressive, thank you. Yeah, Natasha is saying, thanks, Pierre, this is so interesting. Absolutely, totally agree, Natasha. Please, can you explain a bit more about how you're insulating the stone walls, lintels, columns, etc.? Okay,
good question. Right, so in Switzerland or in France, northern France, I just want to put that clearly, you usually have a 300 mil thick stone, and then you've got a vapor membrane, and then 100 mil hempcrete block wall. That's it. Okay. After that, you've got another 10 mil of plasterboard, but that's it. Right now, so that's north of France. In south of France, they don't give a toss because, in fact, the thermal mass of stone is so big, and the weather so hot that, in fact, the way they build is carefully done in a way that they need very little insulation. We don't do double leaf wall in France. It's in France or on the continent. It's very rare. So we rely a lot on the structural mass of the stone, and the insulation, as I say, is usually 100 mil. In Switzerland, the project of Archiplan was showing you the 67 flat. They did 300 mil thick stone and 300 mil thick insulation. So they just didn't use at all they didn't take into account the 300 mil wall, which is a bit silly. They just wanted to have this sort of full 300 mil insulation, but in France it would be just 100 mil. Okay, thank you. Lucy's just asking if you have a comparative table available that takes into account the differing strengths for various materials. It would be more useful comparison than just per square meter. Sorry, can you repeat again? Well, actually, Lucy, do you want to just ask the questions? Pop the mic on.
Thanks very much, Charlotte. Yeah, so Pierre, I've seen only one situation where the actual strength of each material was used, as you were answering my question earlier. You know, steel is much more strong per square millimeter than timber, for example.
Yes.
But it's useful for construction professionals to have that as opposed to just CO2 emissions per cubic meter.
Yes.
Yeah. So is there does something exist?
No.
Okay.
No. No. It's very simple. I think we are on a long way. We're very much like the CLT industry was 20 years ago. Okay. I think it's a matter of time for us. I mean, we are very much leading the conversation on load-bearing stone. We are questioned every day on all those questions about, which is a very good question by the way, Lucy. It's just that we need to go into a sort of grading system, a very pertinent illustration of you know. For so many kilonewton, a Larvik or granite from Norway need to be 150 by 150 when the Burgundy limestone will be 300 by 300. So we need to work that through, but we first need to get the chain of supply right with partners, and we can invest on those partners. So we've got 5 or 6 quarry we are talking with at the moment, which we can go in depth into understanding their material and making this comparison table.
Sounds like a great project for someone.
Yes, I've got plenty of projects.
yeah, so many. And Debbie, she's saying, great talk, thanks Pierre, which is nice to hear. What are the different types of stone available in the UK, and does each type have different properties?
Yes. So for the moment, we've got 2. So, right, compare to the rest of Europe, England hasn't got a wide choice of quarry material. Okay, they've got quarries, but they sometimes do not have the muscle that we have on big French quarry or Portuguese or Spanish quarries. So what we are trying to see is talk to a couple of quarries in Northumberland, Hutton Stone, which are keen to use their sandstone for load-bearing masonry, as well as Portland, of course, Albion Stone, down south, limestone, which are keen also to use all their unloved stone. And both quarries have got different properties, and that's something that we tend to have, we have forgotten, is that in the old days, architect and engineer knew local quarries. They had an intimacy, a closeness with quarry masters. You know, they knew when they were being sent shit to them and were able to say, no, that's not a good stone. And they knew how to navigate the specification of stone. And it has been lost in the last 60 years. So we need to rebuild that. And it's you know, building in stone is an architecture of commitment and of slow learning. But for people who are keen to learn, there is a lot of exciting time ahead.
Thank you. Adam had a comment. Did I read somewhere that stone can be supplied at brick or block sizes, so it's easier to adapt to the new material?
Yes. So Aminta have launched that fashion of stone bricks, because obviously bricks is made of clay that need to be most of the time we need to be put into kiln and so on, which demand a lot of energy. And we all know planners' love for bricks. So to avoid too many issues with planning, decided to see with different quarries, even in England, for example, again, Hutton Stone and Albion Stone are doing stone bricks, that they are more expensive than normal bricks for the moment, but they are low, but their carbon footprint is extremely low. Now, as ashlar blocks, as sort of concrete blocks, we can do that as well. of course, and which make a lot more, how do you call that? Lot more sense to use those big, large blocks that I mean, on large scale project, we use crane to lift them because, you know, past 25 kg, you cannot lift 20 kg, you cannot lift any heavy material. So the beauty of large ashlar module, like we had in France, like you saw on these pictures, is that you can fit a square meters very, very quickly of load-bearing material, which is a big advantage on preliminaries and cost.
Thank you. This is an interesting question. Aidan's saying, what are the different types of cost-effective, sustainable stone flooring?
That's not my strong point, my strong knowledge. There is. So, can you repeat again? I didn't know if it was British or non.
Do you want to put your mic on, Aidan, actually, just so you can expand on your question?
Good afternoon.
Hi. Yes.
I was asking if it's possible to construct a full floor of stone in a cost-effective way.
Okay, a load-bearing stone floor.
Yeah.
Yes, we can do that.
Like
yes.
the ground floor of a building. Or...
Yes, we can do that. We already do that. We compared to a concrete one, we would be around 10% more expensive.
Okay.
Okay, I think we've got another cost-based question actually from Elvid.
Oh, you are so vulgar with all your cost question, really. I mean, I'm trying to make you read to dream, and you come with money questions. I'm so disappointed.
Oh well, I think people are keen on using stone, but they've
no, I'm joking.
So Elvid actually developed some affordable housing, and he's asking, how does stone compared to the cost of the usual house building materials like brick and concrete? Hi, Elvid.
So that's interesting. So I'm going to be as clear as possible. If you take a high-end finished cast concrete product, okay, precast, high finished precast concrete system, right? You know, this sort of tectonic finish you have honed and so forth. Then our stone structure with that same finish are exactly the same cost. Okay, so what I mean is, because our products are going to come with a finish that is superior to any concrete or other concrete finish, so you don't need to add any other finishes to our structure. You don't need to hide anything. You know, they can be left alone because they are already a beautiful finished product. So then we compare well with any other way of construction. Does that make sense? Does that sort of make sense?
Feel free to pop your mic on if you have any follow-up questions or want to comment.
Yeah, I mean, obviously, I work in Wales, where there's an enormous tradition of building houses in stone.
Yes.
Much like you know, using slate obviously is the most infamous material from Wales. Obviously, with affordable housing, which we have to develop to fit within a certain cost parameter, going back to the quarries now and specifying stone instead of timber or bricks does, on the face of it, seem more expensive. I can understand why extremely important buildings in towns and cities should be built from stone, because they everything needs to be built to last. And when you look at the work that Armin has done, you can see that fitting in with the tradition of buildings which will last centuries. You know, so unfortunately we operate in such ridiculous cost constraints, you know, that we have to ask these questions.
No, of course. So I think again, it's a question of will and commitment with the team doing and developing this affordable housing scheme. If the developers is intelligent, there is a good chance he's going to get an intelligent architect, then an intelligent engineer, and an intelligent QS. And then with the quarry owner, maybe intelligent or she intelligent as well, you can come with strategy to use your material as efficiently as possible. I think one of the secrets is, of course, to try to find a way to prefabrication in a controlled environment in the stone yard or at the quarry, so that you can bring paneling system in place. Okay, that is something that should be looked at, and that's the beauty of, the romantic beauty of working with stone is that each local area is going to develop its own stone architecture, in fact, and it's where it's starting to be what I call fun, which about the fun of building and construct and constructing for the health of everyone. But I do understand that if tomorrow you've got to have your Barrett house and you want to have the same cost as stone with a local material, I don't think you are going to reach that. No, not yet. No, I think. But always happy. Good. But always happy if you have got any future question about that. Please do send me an email saying, look, that's the material. That's what we want to achieve. Is it possible? And I tell you quickly if there is a way or if there is not. Pleasure.
Excellent, thank you. We've got a few more questions coming through. Yep. I know we're a bit over time, but
that's fine. That's fine.
Are you happy to stay on?
Yeah. My cats have eaten, so I'm fine.
That's good to know. I'm glad the cats are happy. Yes. So I just wanted to roll back to Natasha's question. She said she's missed the introduction, but Pierre, is your work based in the UK, and is your mission to bring load-bearing stone to the UK in the same way as it's used on the continent? No, because we're Britain. We're different. No, no, because I think we need to be a lot more. Okay, we cannot have the same architecture as we have on the continent, because I think it would be pretty damn stupid to bring huge amount of stone as load-bearing walls like they do in France, and to bring them in England. I think in England we should use what has been achieved in the last 20 years by doing framing system, stone frame system, light prefabricated units, so that you can do a sort of carpentry of stone elements, which will be a lot lighter and which allow you to then infill with local material. Okay, so I think it would be a bit counterproductive to bring these pieces of mountain from France or Portugal or to the UK. I think we need to be a bit more clever, because then otherwise we're going to finish like the concrete industry, importing huge amount of cement or of sand to the UK, and I don't see the point. I think we need to work with a lighter system, made this element be lighter, but coming from the continent, or being built in the UK.
Thanks, Pierre. It's Natasha.
Hello.
Hi there. Just on that point about the infill material. So, yes. How much work is being done on what that infill material will be, or can it be anything that we're using in our construction at the moment?
Exactly. I mean, that's what we want to do. With this sort of framing of lintel and beams, columns and beam system, is just after that. If you go at Clerkenwell Close, for example, that whole back facade, the sort of internal facade, has been made with steel, wood, and glass. But it could be anything, and you could reuse even non-load-bearing material like local limestone or wood or thatch or whatever, and you can have a lot more fun than before. I think always something I want to stress on staying on. Not on high rise. What I mean is, I think those architecture we are talking about are no more than 10 floors up. Okay. That's all. See, is important not to go too high as a high rise. Yes.
Thank you very much for your thoughts. Richard's asking, for difficult to access sites, is it feasible or practical to post tension stone elements on site?
So no, it's feasible. It's feasible. It's like any post tension system doing for concrete. It's exactly the same sort of issues. We all our staircases in the past were post tension, so they were staged done on site. But you could very much have a sort of prefab stone elements, which you will have another system of holes that would then be able to post tension those different beams and column all together, like traditional post tensioning concrete system.
Thank you. That's good to know. Zach, thank you for your question. How much over-engineering is needed to factor in potential natural fissures, defects within stone itself, but still maintain structural integrity? Yes,
so good question. That's, again, it's something we are trying to go at the bottom of it. It's something that the stone industry hasn't done, which is a grading system like for wood, where you've got a grading system for wood. We will need to go through a grading system for construction stone, so that stone that's going to be put back into compression could have a certain amount of fissures and cracks, and you've got factor of safety built into it. We are looking at using non-destructive testing technology based on soundproof on sound testing stone, just to see if there is any other internal fissures that we don't see, or cavities. So that whole process is being put in place by us, only us, at the moment. And we just hope that other people will catch up that sort of technology with us, so that we can get data, a lot more data than we have at the moment. But all our stone structure are built with the collaboration of engineers who have learned about stone, who know stone, and stone is anyway always tested along the way of the project.
Wonderful. Okay, I think we've got time for one more question, so we have gone a little bit over time. Can you say the pros or benefits in the practice of quarrying in contemporary environmental concerns?
Can you repeat again?
Can you say the pros or benefits? Can you say the benefits in practice of quarrying in contemporary environmental concerns? So how do you sort of justify?
Yes, sorry. So it's about extraction.
Yeah.
Yes. Okay. So there is some few good news recently, is that to extract stone, if you extract stone with wire technology, the big wire, you use water. Okay. Normally, a good and ethical quarry master will always recover this water, okay, reuse it into the system, and so on. All right. Unfortunately, not all quarries do that. And sometimes the bad press that you can see in some, especially in Italy, in Carrara, where there is some sort of Wild West in stone extraction, or other part of France as well. It's not only Italy, and so nowadays they you extract stone with this giant chainsaw that I saw you before, which doesn't need any water, which means that it's a completely dry and only electric with only electricity. So it's a very clean it's a very clean environment. We do not, especially in England, you rarely use black powder to extract stone. So that's the good news as well. No more fissures created by the explosion. Stone quarries are fantastic when they are at the end of life, because usually they are going to be used as a rewilding biosystem. And quarries, a quarry owner by law, especially in France, but it's the same in England, have to put back the quarry to its sort of original state, and if not, to have a rewilding program for anything from flowers to flora and fauna. And it's an extraordinary thing to see quarry put back into the wild. It's really amazing. Or it can be used as well as reservoir, water reservoir, and even used by developers to put hotels into quarries, Discrete Quarry, like it's done in China. So there is a huge amount of things to do.
Very good.
Thank you.
Great stuff. Excellent. I think we better leave it there because people are probably getting hungry. Just want to say thank you so much. Yeah, it's been brilliant.
No.
Really, yeah, it's kind of a new topic for us, really. So we'd love to have you back at some point. And I hope everyone else has enjoyed it. Thank you all for being here and contributing as well. And I've just got this image of you in a quarry walking on a plinth of greatness, as you said earlier.
Sorry?
I just love that, and I want to.
No. I mean, I can only thank you to have taken the time, all of you, of your Monday evening to learn about stone. Please do not hesitate to send me questions. I'm used to have plenty of it. It will be a pleasure to help you. You will never bother me. I'm French. I will tell you if you bother me. So please do send me all your questions, and please let's make of use of our beautiful stone.
That's wonderful. Thank you. So I suppose on that, I can say that we can share the recording a bit later in the week when it's sort of processed and things. And with that, we could maybe include Pierre's contact details, if that's okay.
Yeah, of course. Yes, do that.
Fantastic. All right. Well, thank
you so much.
And
thank you.
We hope to see you very soon.
Super. Thank you very much, guys. Thank you.
Bye-bye.
Thank you. Bye-bye. Thank you.
Bye.
Bye-bye.
Yeah.